The topic is the science behind Cristiano Ronaldo's unstoppable free kicks. Cristiano Ronaldo, this name is known to you. He is a famous football player, and we are here going to analyze the science behind his unstoppable free kicks. His free kicks are absolutely unpredictable to the players of the opponent team as well as the goalkeeper. And since these are unpredictable, actually his intention is to make unpredictable trajectories of his ball kicked by him. Okay. So that point we are going to analyze here in this discussion, how this is possible. There are mainly two reasons. One is a Magnus Effect. Okay. In the subject of fluid dynamics, you can study this effect, Magnus Effect. And another one is Knuckleball effect. Both are related to fluid dynamics or aerodynamics. Okay, let us first consider the case of what? Magnus Effect. Say there is a cylinder. There is a circular cylinder, and that is kept in a horizontal position, and that is being rotated. Okay, with certain angular velocity. So when the cylinder is rotating around its own axis, then in that case what happens? A force in the upward direction acts on that cylinder. This is known as Magnus Effect. This effect is used by Cristiano Ronaldo to make his unpredictable kicks. Okay. So how he is done? First, when he strikes the ball with his feet, when he strikes the ball, so in that case what happens? The ball moves in the forward direction as well as the ball spins around its own axis. Yes, he kicks such a way to move both the things simultaneously. One is forward motion, another one is spin of the ball. So here what happens? Two sides of the ball, if you consider two sides of the ball, then on one side the air flows in the same direction of the movement of the ball, and in the opposite side of the ball the air flows in the opposite direction of the movement of the ball. So the side on which both the directions are same, therefore what happens? The airflow increases. The speed of the airflow increases on that side. So since the airflow means velocity of the airflow increases, that means pressure decreases. And on the opposite side, the speed of the air decreases, that means pressure increases. If you apply Bernoulli's theorem, you can easily analyze this. Okay. So when speed decreases, pressure increases. So you can see that on either side of the ball there are pressure differences, and due to these pressure differences a net force acts in the direction of movement of the ball. Okay, it is this force acts in the perpendicular direction to the movement of the ball. So there is one motion of the ball, forward motion, and another one is the force due to Magnus Effect. So by the combined effect of these two forces, the ball follows a trajectory, and that trajectory is decided by the player, Cristiano Ronaldo. Yes, Ronaldo has become expertise in this field. In this game he has become an expert. He knows very well how to kick, in which angle to kick, how much spin to provide to the ball, so that according to his own will, the ball moves in the desired trajectory. Okay. So this was all about the Magnus effect. This is one reason why the ball moves in an unpredictable trajectory. Okay. Next one is knuckleball effect. For knuckleball effect, what is required? A powerful strike to the ball. A powerful strike on the ball is required, and that is possible by Ronaldo. Powerful strike is required. Okay. And next is when the strike is made with his instep of the foot, then in that case what happens, the air surrounding the ball starts rotating. There is a great movement of air surrounding the ball. So what happens, the ball moves in a certain direction, and behind the ball there is a formation of turbulent wake zone. And this formation of turbulent wake zone behind the ball makes the direction or the movement of the ball totally erratic in nature. And this is also desired by Ronaldo. He is also got expertise in this type of kicking. Okay. So actually he knows very well the aerodynamic of ball. Again, texture of the ball, means surface texture of the ball, that also matters. Depending upon the surface texture of the ball, seam of the ball, air flow changes, and that is also known to Ronaldo, and accordingly he can take his decisions. Okay. But here in the game of soccer, okay, these decisions need to be taken within a fraction of a second, and Ronaldo knows everything. He is able to take decisions, the required decisions, the perfect decisions within a fraction of a second, and accordingly he can execute the desired things. Okay. So one more thing is there, weather condition. Say at high altitudes, you know that at high altitudes the air pressure is low. So accordingly resistance to the ball due to air will be less. So in that case ball can move further for the same kick. Okay. Again, temperature matters, again humidity matters. Okay, if humidity is more, then the density of air becomes more. In that case, there is an extra restriction to the movement of the ball. And Ronaldo and his team are well aware of all these things, and accordingly they can take their decisions. So all these things were the science behind Ronaldo's unstoppable free kicks. Anyway, he knows everything, he knows aerodynamics. That doesn't mean that you know aerodynamics very well, so you would become an expert in the game of soccer. Not like that. You need to practice your knowledge repeatedly on a daily routine basis. Okay, daily you have to practice. Repeatedly you need to practice the same thing. Just gaining the knowledge of aerodynamics can't make you an expert in soccer. Anyway, so this was all about today's topic, the science behind Cristiano Ronaldo's unstoppable free kicks. So only powerful strikes are not sufficient. The desired thing is you have to make the movement of the ball unpredictable by the players of the opponent team. as well as by the goalkeeper. Okay. Everything will be known to you a priori, but the opponent should not know the trajectory of the ball. That way you have to kick the ball. And this type of expertise has been acquired by Cristiano Ronaldo. Okay, anyway, so this was all about today's topic. This is the end of this video. Thank you for watching this video.